Hi! In this lesson, I'm going to talk about the discovery of the protons. Well, who's the scientist who discovered protons? In 1907, Ernest Rutherford had discovered the protons after doing some experiments with his co-workers. But before Ernest Rutherford discovered the protons, in 1897, the British physicist J.J. Thomson had discovered the electrons, which are abbreviated in these days as E-. And he discovered them using the cathode ray tube experiment. And I have a video about it in the playlist. You can check it out first. Okay, so what did Ernest Rutherford do here? Well, Ernest Rutherford had just saw that there's the atomic model of J.J. Thomson, which he discovered, and had decided to discover something or create an atomic model. But how? He used that gold foil experiment, which is called the gold foil experiment. What is it? Well, Ernest Rutherford and his co-workers had just put a zinc sulfide covering around a thin layer of gold, and then had a lead coverage which had a radioactive sample inside which shot alpha particles. Well, after the alpha particles were shot, Ernest Rutherford was shooting alpha particles. He was very surprised when he saw that one of the alpha particles, of course, he saw the alpha particles going through the gold foil normally and then glowing at the end because the zinc sulfide is acting as a fluorescent screen. So he saw that, okay, they're going through it. But then the point that got him surprised is that while he's shooting the alpha particles, he saw one alpha particle just changed its route or route. It got deflected. He was super surprised. So he thought about it. He tried to do the experiment again. But what did he do now? Of course, out of thousands and thousands of shots, only one got deflected. So he tried the experiment now again, but he wasn't shooting the alpha particles repeatedly. He shot them now one by one. Damn, it will take a lot of time. Okay, so he shot them one by one, and again, out of thousands and thousands of shots, one got deflected again. And here it got deflected. So Ernest Rutherford and his co-workers were sure that there's something inside the gold foil that made it deflect, and surely the atom itself. He said if J.J. Thomson had his atomic theory correct, if it was correct, then why did the alpha particles why did they get deflected? Shouldn't they just go through it? Well, no, he discovered that it shouldn't. Because he said that surely what's deflecting that alpha particle. Now remember, an alpha particle is positively charged. So it should be something that's first thing positively charged and should be heavy. Why? Well, because the alpha particle, there are two protons and two neutrons, which is a helium atom but without electrons. So I shot those, which are positively charged, to the gold foil. So no way it would get deflected if first thing there were no similar charges. Okay, no similar charges. Plus, if there's no hard, dense thing that's keeping it away or kicking it out as soon as the alpha particle touch it and deflects it away. And of course, the charge helps in that. Okay, I think some of you didn't understand what happened. Let me draw it for you. So we said that Ernest Rutherford was shooting alpha particles at the gold foil and saw them getting deflected. So he said that surely something that is positively charged in the middle of the atom is deflecting it. But why? If we look at the atom, here we have the electrons just randomly spread, and the alpha particle is going through, and then suddenly it hits something that deflects them. What does that mean? It means there's something here in the middle of the atom that's kicking it out, and he called them protons. Well, what are the protons? He discovered that the protons are first much heavier than the electrons. He discovered another thing, which is that protons are also positively charged. So he said that the alpha particles are going through and hitting the protons, and they're getting deflected. And that's what's actually happened. They got deflected every time they hit the protons. So then he said, well, J.J. Thomson's atomic theory is actually wrong. So he proposed his own atomic model, which is not the plum pudding, another atomic model. He said that protons are resting at the middle. They are at the middle of the atom, and electrons, which are smaller, are randomly spread around it. Make that way so you can see it. So they're randomly spread around it. This is Ernest Rutherford atomic model, and he proposed that most of the atom is vacuum, empty space. So this is the discovery of the protons, and of course protons are now just abbreviated as P+. Okay, so let's do a quick recap of what happened. Ernest Rutherford shot alpha particles into a gold foil. What happened is that he saw the alpha particles getting deflected. So he thought, what is that thing that's deflecting the alpha particles if the atoms are, as J.J. Thomson said, they are having electrons randomly spread around it. And yeah, he said electrons are spread around it randomly, and there's protons, of course, in the atom. Or positively charged things. He didn't say protons. Positively charged things. Why did those alpha particles just didn't go through it? Well, he said, of course, there's something in the middle that's preventing it. Because every time he shot an alpha particle, it would go through. Okay, it would go through, but one out of those 1,000 shot won't go through. So he said that probably there's something hard, dense, and positively charged deflecting those alpha particles, and then he called them as protons, and they're abbreviated as P+. And then he provided his atomic model, which is the protons in the middle and the electrons are randomly spread around it. So that's the discovery of the protons. And that's all about our lesson for today, and I hope it was useful. And I hope if you want to watch, you want to learn more about the atomic model, it's better to watch the first video, which is about the cathode ray tube experiment, which is the discovery of the electrons by J.J. Thomson in 1897. So, this is all about our lesson for today, and I hope it was useful.